Hello everyone. Is my voice audible? Yes or no? Tell me. Is my voice audible? Is my voice and video both are okay? Tell me guys, is my voice audible? Yes or no? Good evening Komal. Good evening Sayan. Good evening Reddy. So hello guys, welcome to the next power pack session of a network theory. Okay, welcome to the next power pack session of a network theory, and that we have done first class in a yesterday. So guys, this is the second class of the series, and right now we are doing today class. The topic will be the concept of symmetry. Hello Himanshu, बेटा चंदन सर has taken a classes. चंदन सर पहले आपके digital class ले चुके हैं. Right now I am taking a classes on network theory. And one of the class, the first class I have already taken yesterday. Okay, so in a yesterday class, the main topics that we have discussed was the concept of capacitor. One of the most important concept we have discussed in a yesterday class, and that was the concept of capacitor. What was the concept? What was the concept? The concept was, if the capacitor are connected in series, the charge remain constant, and if the capacitor are connected in parallel, the voltage remain constant. Okay, so this concept is very important. Okay bacha, so good evening to everyone. Yes Polyreddy, this is the continue of the last session. In this we are going to learn how to calculate or how to ease the network using a concept of symmetry method. So if you are watching me first time, so first I will intro myself. My name is Ishan Mudgal. I have a 3+ year of experience and 5 times GATE qualified MTech gold medalist from NIT Allahabad, and these are my area of expertise. If you want a revision series also on power electronics and power system, you can follow me on a GradeUp app. For the follow, you can we have a description. We have a follow link in a description. So from the description, you can follow me on a GradeUp app, and you can watch the revision series free of cost. Okay. So before starting the today's lecture, before starting the today's main topic, first of all, what I am going to do? First of all, I am going to do one question based on the previous class topic. Okay. Okay, so this is the first question. So see this question and try to solve this question. And see everyone, this is a MSQ type of question. So remember, for the MSQ type of question, it may happen that more than one answer will be correct, or it may happen that all the answer can be correct. Okay, I am very good, Kanzilia. How are you? And Himanshu, I am currently in second year. Yes, Himanshu, you know, if you are in second year, you have already learned this particular subject in the first year. So it's very helpful for you, because when you're going to start a GATE preparation, the first subject must be the network theory, because network theory is the base for every other subject, whether it is of your analog or it is your power system, machines, communication, whatever subject you pick, you have to use the concept of network theory. That's why it is going to be very important. Okay, Reddy, you are asking, sir, last session one problem given homework, that answer. Okay, that answer I will give in the end of a session. Okay, Reddy, that answer I will give in the end of a session. So first we will start our session with this question, and here I am going to tell you one important property of a DC circuit. Okay, so everyone try this question, and guys don't forget to like the session, because the your attendance will be equal to the how many likes I get in this session. Okay, and guys, if you have any doubt, you can ask. And okay, here it is IL. Here I have IL. Okay, just a typing mistake. Okay, so everyone try to solve this question. Okay, so let me read your comments. So yeah, Chinna Reddy. Okay, Chinna Reddy has given the answer option B and D. Very good. And Himanshu is saying, currently I'm having network in my semester. Yes, Himanshu, if you are having a network in your semester, so I guess you are in first year or second year, right? So let's see. We will discuss very important concept behind this question. So as I told you, in our revision series, what we are doing, we are first seeing the question, and from the question we are learning the concepts, so that you will get revised both concept as well as the question. Okay, so let's see. First of all, I will tell you the concept behind this question. The concept is very simple. The concept is very simple. What is the concept? For DC supply, if the supply is DC, for DC supply, concept is very simple. For DC supply, capacitor act like a open circuit. Capacitor act like a open circuit and inductor act like a short circuit. Now you may ask, sir, why this happen? You may ask, sir, why this happen? Because you know that capacitive reactance is equal to 1 upon omega C and inductive reactance is equal to omega L. At DC, what happened? What is the frequency at DC? At DC, frequency is going to be 0. Yes or no? For a DC signal, frequency is 0. So if you put 0 here, then capacitive reactance comes out to be infinite. Infinite reactance means open circuit. Similarly, inductive reactance comes out to be 0, or you can say 0 means short circuit. So always remember, for a DC supply, capacitor act like an open circuit, inductor act like a short circuit. Okay, so this simple concept we should understand while solving this question. So here you are seeing, here you can see, okay, this is actually plus 1 by 3. This is actually plus 1 by 3, typing mistake. This is actually a plus 1 by 3. So here you can see I have a DC supply. So if I have a DC supply, so what thing I can do? I can short circuit the inductor and open circuit the capacitor. So see here very carefully. See here very carefully that I have a DC supply. So inductor is short circuit, capacitor is open circuit, and this is also an inductor. This is also become short circuit, right? This I have a supply of 1 volt. So guys, this has a resistance of 1 ohm. Here see the polarity. Polarity is very important. Whatever the polarity or direction of current is given in a question, you need to find answer in that polarity and in that direction. Simple si baat hai. Okay. So see here very carefully. Now what will be the inductor current? What will be the inductor current? So beta, when you see this question, see very carefully. Here I have only 1 voltage. So the current will flow in this direction. It will flow in this direction like this. It is open, so no current is going to flow. No current is going to flow in an open circuit, obviously. So inductor current will be how much? Voltage, inductor current, voltage divided by 1 plus 2 resistance is equal to 1 by 3 ampere. Meaning voltage divided by resistance of a part. It comes out to be what? 1 by 3 ampere. So option B is the right answer. Option B is the right answer. Option A is the wrong answer. Now I have to find out capacitive voltage also. Okay. But you have to take care very carefully the polarity of a capacitor voltage here. Okay. So from here I know that IL current is flowing. So polarity will be plus and minus. Polarity will be plus and minus. So I am just applying the KVL in this section. In this section, I am just applying the KVL here. So if you apply the KVL here, the KVL equation will be, here you can see minus 1, the polarity is plus here. So plus IL multiplied by 1. Now here I have a minus VC equal to 0. So capacitive voltage comes out to be minus 1 plus IL. What is IL? IL is 1 by 3. So minus 1 plus 1 by 3 is how much? Minus 2 by 3 volt. Minus 2 by 3 volt. So answer B and C are the correct options. So answer B and C are the correct option. So let me see who has given the right answer. So I will see in my phone. So guys, right answer is given by no one. Swati has given the right answer, correct? And anyone else? Then no one is given the right answer. So beta, this is very important. Okay. Now there is some doubt by Himanshu. Sir, which book is best for ESE which contain previous year question chapter wise for ECE branch? Himanshu, if you want a previous year question for ESE, The best book for network theory is Alexander Sadiku. Alexander Sadiku's best book, and if you see this book, you will get to know that previous year ESE question, that direct question has been come from this particular book for ESE. For GATE also this book is good, but as you know, in GATE question doesn't repeat, concept repeat. So for ESE or GATE, you can follow this book, and for ESE, you can see the direct question coming from this particular book. Okay. Okay, fine. So for this question, you need to remember the concept that for a DC supply, capacitor will act like an open circuit and inductor will act like a short circuit. Now, what happens if I have an AC supply? A question has been asked by a student. What happens if I have an AC supply? The simple thing is that in case of AC supply, you have to put capacitor in terms of the frequency form, which means 1 upon omega c. And you have to write the inductance in terms of the reactance form, and then you have to solve the question. So when we see the AC question, there you will see how to treat the capacitor and inductor in case of AC. Okay, but this is fixed for DC supply, always remember. Okay, any doubt here? Next Himanshu beta, you can note down the name of book from here. Alexander Sadiku. This book you can find out in a PDF form online also. So just type this name on a Google. You can find out the book in a PDF form. Ready? Actually, course is same for ESE and EE. So the book is going to be same, Alexander Sadiku. But for more practice, what you can do? You can also follow the book of or for the questions you can follow the JB Gupta also. But for theory, Alexander Sadiku is best. If you want to follow the theory, Alexander Sadiku is best. For questions, you can follow different books also. But first, you have to complete the previous year questions. Right? Now, everyone solve this question. Try to solve this question and give me the answer. This is a very beautiful question. Has been asked 2 or 3 times in a previous year GATE question, both in electrical and EC branch. And this type of question is known as the ladder network. This type of network is known as the ladder network. Okay. Okay. Very, very important. Very, very important. Okay. Ashraf Ali, Asfar Ali, for the books recommendation, you can go to our website and there you will see the best book for each and every subject. Okay, for control, analog, communication, you can see each and every best book. But for a control system, I forget the name of a book. Actually, I forget the name of a book. For analog, you can follow the Hayat also. But you can go to our website and there you can see each and every book you can prefer for the GATE as well as ESE exam. Okay, good. Now everyone try this question. Now what is special in this question? You need to understand very carefully. What is special in this question? You need to understand very carefully. First of all, observe beta. What is the meaning of this dash line? The meaning of this dash line is that the network is repeating till infinite times. Mean the same network is going to repeat till infinite times. Okay, that's why this is known as the ladder network. That this network is going to repeat till infinite time. Now, how to solve this type of question? So there is a trick to solve this type of question. Does anyone knows the trick? Good. Tharun Ravi has given the answer. 4.6 Henry is very good. Let's see the answer is correct or not. And Ashraf, I remember the name. The B.S. Manke is the best book for a control system. B.S. Manke is the best book for a control system. Okay. So guys, here I can see the network is repeating till infinite times. Now there is a trick to solve this type of question. First of all, step one. सबसे पहले तो आप ये देखो. First of all, you should see one point here. Is any branch is in series or parallel? First of all, you have to identify, does any branch is in series or parallel? Yes or no? कोई भी branch series या parallel में है? Yes or no? Is any branch is in series or parallel? Yes or no? Jaldi se, quickly give me the answer. Is any branch in series or parallel? The answer is no. always remember one point for parallel connection. For parallel connection, you need to understand one point, very, very important. For parallel branch, a two branch can only be parallel. The two branch can only be parallel if both the terminals of the branch are interconnected to each other. If both terminals are not interconnected to each other, then two branches are not going to be parallel. For example, see this question. The one terminal is connected to this. Okay, obviously 2 Henry and 1 Henry. One of the terminal is interconnected. Okay, but the second terminal is not connected to its second terminal. That's why no branch in this question is in parallel. Then how can we solve this question? So there is a trick to solve this question. It's a very beautiful trick. First step is to identify the repeated branch. Identify the repeating branch means you have to identify which branch is repeating. Identify the repeating branch. So first you need to identify which branch is repeating. So see here very carefully. This is 2 Henry, this is 1 Henry, 1 Henry, 1 Henry, 1 Henry. So you will see this branch is actually repeating infinite times. This particular branch is actually repeating infinite times. So first you have to identify which part of a network is repeating infinite times. Now think about one thing. If I add infinity plus 1 or if I subtract something from infinity, the answer will be infinite, yes or no? Answer will be infinite. If I add one thing in infinity or subtract one thing from infinity, the answer will be infinite. So what I'm going to do, first of all, you have to identify which branch is repeating. After that, after identification, I will assume the resistance of all repeating branch is equal to X. Then I will assume resistance, or here I am saying inductance. Inductance of all branch is equal to X. So what is the step 2? Assume inductance of repeating branches. Inductance of repeating branch till infinity. Till infinity is X Henry. Okay, if I have a resistance here, then it will be R ohm. Okay, no change. So it will be X Henry. So what I will do now, I can redraw my network like this. Now I can redraw my network like this. See very carefully. I can redraw my network like this. This is X Henry representing all the inductance here. This is 1 Henry. This is 1 Henry. This is 2 Henry. This is 2 Henry. Yes or no? I hope you don't have any doubt till here. You don't have any doubt till here. But if you have any doubt, you can ask. If you have any doubt right now, guys, you can ask freely. So here you can see, I am assuming the repeating branch till infinity has X Henry. Okay, so this is the X Henry. Now think about this concept. If I add infinity plus 1 or if I subtract infinity minus 1, the result will be infinity. So in this repeating branch, if I add the same branch, see this 1 Henry, this 1 Henry is same. So in this repeating branch, if I add the same branch, then also inductance is going to be X. It means the inductance of this portion is also going to be equal to X. Why? Because in infinity, I am just adding the same thing. In infinity, I am just adding the same thing. So the inductance going to remain same. It means what? The resultant of this portion, which is X plus 1 parallel to 1, is going to be equal to X. It means X is equal to, X is what? This X is equal to, these two are in series. So X plus 1 is parallel to 1. So from this equation, I can find out the X. So I will repeat myself again. See this question very, very carefully. When I assumed this is a X, then I'm adding the same branch. So if I'm adding plus 1 in infinity, it is not going to change the network. That's why the inductance is remain X only. Okay. So from here, this equation, I can find out the value of X. From this equation, I can find out the value of X. So it comes out to be X square plus X. minus 1. Just check my calculation. If you think my calculation is wrong, you can tell me. So from here, x will be, use the quadratic formula. Use the quadratic formula. B square minus 4ac divided by 2a. X is equal to what? Minus 1 plus minus root 5 divided by 2. Now resistance cannot, sorry, inductance cannot be negative. So x will be what? Root 5 minus 1 divided by 2. So this is the inductance of this portion. So this network can be changed into what? This network, bachcho, this network can be changed into this particular network. Yes or no? Yes or no? Now finally the inductance L that I need to find out. These three are in series. So L will be 2 plus 2 plus x. It means 4 plus root 5 minus 1 divided by 2. 2 4 ja 8 minus 1, 7 plus root 5 divided by 2. This is the answer. Okay. You can convert this into a decimal also. But this is the answer. Okay. Okay. Now ask your doubts. Ask your doubts. I want everyone to ask the doubts. So let me read. Swati is going, we have to solve the quadratic equation. Yes, Swati. Vinay is saying repeating branch is also 1 Henry, starting also right, sir. Beta, again, I will explain this thing. You have to first identify the repeating branch. So you can see this branch is going to repeat every time. So I will keep one branch here and I will assume the inductance of repeating branch equal to x Henry. And when I assume that, I'm just adding the same branch here, so it is not going to affect the inductance if same branch is going to add just once. So the inductance is x Henry. So here I can say this is x plus 1 parallel to 1 is equal to x. And then there is a quadratic formula, fine. And you can see I need to find out inductance from here. So here I can say I have 2 Henry, x Henry and 2 Henry. Simple. And this type of question has been asked 3 to 4 times in your previous years. Okay, that's why it is going to be important. Any doubt here, you can ask. If you have any doubt, you can ask. Because I am going to give you one very, very beautiful question for your homework. On the same topic, I am going to give you very beautiful question in the homework. And the same question has been asked in a GATE exam also, that I am going to give you that. Okay, Sheikh is asking, yes, Sheikh. If the resistance is present or the capacitor is present, you have to follow the same thing. Okay, actually in your exam, the same question has been asked in a form of resistor. But you have to keep care in a capacitor. In capacitor, you need to take care the formulas. The formula is going to be reversed in case of a capacitor. Procedure will be same. There is no problem in a procedure. Procedure is going to remain same. Okay. Okay, Kanzia, tell me what you didn't understand. What you didn't understand, Kanzia, tell me. Okay, Shubhrajit asked, sir, I am in a class 12 pass out. Which branch should I choose to study microprocessor, CPU design, how processor? Understand? Shubhrajit, beta, I don't have any much knowledge about the microprocessor. Actually, I am from electrical field, so I have not have much knowledge about the microprocessor. Okay. Kanzia, you see the video again when after a class, see the video again. If you again can't find out the solution or didn't understand, then I will explain you after you can ask in next class also. So guys, in a homework question, this is a very beautiful question, has been asked in 1993. Okay. What is the question here? See very carefully. I have a grid here. I have a type of grid which is increasing at an infinite portion. Means it is going to be increased at an infinite times. Okay. And there is a two node A and B. Question is find resistance between AB. Question is find resistance between AB and each branch has a resistance of R. Find resistance between AB and each branch has resistance R. Each branch has resistance R. So take the screenshot for this question. You can take the screenshot or you can just note down this question. Each branch here has a resistance R. Remember, each branch here has a resistance R and this portion is repeating infinite time in all the directions. In all the directions, okay? Okay, Som is asking what if the element are in AP or GP? Beta, element will not be in a AP or GP because we are actually dealing with the networks. In the networks, elements are not in a AP or GP. Otherwise, it will be increase the value continuously, and practically the power loss will be high. For the symmetricity, we have to keep the element actually in the same value. Okay, guys, this is your homework question. I hope you will try it. I will solve this question in the next class, but I want each one of you at least try this question. Okay, now next I'm going to start a symmetry concept. Okay, so today's the class topic is symmetry concept. So here I'm going to start the symmetry concept. Okay, Arjun has already given answer. Good, Arjun. So what is the symmetry concept? One of the most important concept. Why this is important concept, bachcho? Because in the last 6 to 7 years, okay, from 2012 to 2020, 6 question has been asked on this concept, including both electrical and ECE. That's why it is a very important concept right now. So this question has been asked again. This type of question has been asked again in your GATE 21. Okay, so what is the concept of symmetry? Concept of symmetry term is basically used to identify the equipotential points. To identify the equipotential points. This concept is basically used to identify the equipotential points. Okay, once you identify the equipotential points, then you can decrease the complexity of a network. Then you can decrease the complexity of a network. Okay. Okay, so let's see what is the meaning of a concept of symmetry. So I'm taking one question. I'm taking one random question to explain you the concept of symmetry. So this is a random question I'm taking right here. This has a resistance R, this has a resistance R, and 2R. Now in this question I need to find out resistance between AB. Okay, simple hai. In this question I need to find out resistance between AB. Now guys, this question can be solved by using the Wheatstone bridge concept also. Okay, no problem. This question must be solved by that particular concept. But I am explaining you the symmetry concept by using this question. Okay, but I am explaining you the symmetry concept by using this question. So there are some steps for the symmetry concept. So I will take the step one by one. The first step, check whether the circuit is symmetrical or not. Okay, you have to check whether the circuit is symmetrical or not. So check that circuit is symmetrical or not. For this you have to draw a line. Okay, you can draw either vertical line or you can draw either horizontal line. Let us suppose I am drawing the vertical line. So if you draw the vertical line, so see this very carefully. If you draw a vertical line and see both sides of a network, the network is exactly the mirror image to each other. Yes or no? If you draw the vertical line, see both sides of a network, the network is mirror image to each other. It means this network is symmetrical. So the first step is to identify whether the network is symmetrical or not. And again, if I draw one horizontal line, then again I can see above this line and below this line, I have a same mirror image. Above this line, below this line, I have a same mirror image. So again, this network is symmetrical according to this line also. So it may happen that a network is symmetrical using the two lines, or a network is symmetrical also again by one line. Okay, so this may happen. But one thing you should understand that if you only need one symmetrical line to solve the question, you only need one symmetrical line to solve the question. Okay guys, so first step is to check if the circuit is symmetrical or not. Okay, next, identify the line of symmetry. What is the line of symmetry? Now line of symmetry is of two types. First is a parallel line of symmetry and next is a perpendicular line of symmetry. Okay, now you will ask, sir, what is parallel line of symmetry? So beta, what is parallel line of symmetry? For that you have to draw axis of a network. This is a axis of a network. This is what? this is a axis of a network. Okay, so this is the axis of a network. Yes or no, guys? Yes, this is the axis of a network. So beta, for the axis of a network, first you have to see if the line is parallel to it. If the line is parallel to it, that become the parallel line of symmetry. And if the line is perpendicular to it, it become the perpendicular line of symmetry. So the first two step is to check whether the line is symmetrical or not, and then you have to check whether the line is parallel line of symmetry or perpendicular line of symmetry. Okay, okay. Now if you have any doubt, you can ask till now. So Chinni, you are asking, yes, Chinni, this is the same topic I have already taken on the Grade Up app revision series. Okay, here this is a YouTube revision series, so I have to repeat it again. Okay, but yeah, I have already taken the same concept in a Grade Up app earlier. So beta, these are the two steps. Now next step is very important. This step need to see very carefully. For parallel line of symmetry, branches which are perpendicular contain equipotential points. Means if the line of symmetry is parallel, if the line of symmetry is parallel, for example, this is a parallel line of symmetry, the branches which are perpendicular to it contain equipotential points. So you can see the branch CD is perpendicular to it. So C comma D are equipotential points. C comma D are equipotential points. Very important. C comma D are equipotential points. Now again, if you have a perpendicular line of symmetry, then branches which are parallel to it contain equipotential points. So here you can see, in case of a perpendicular line of symmetry, again CD is parallel to it. Again you will see very carefully, CD branch is parallel to it. So C comma D are equipotential points. So what is the conclusion I get here? You can use any line of symmetry, either parallel or perpendicular. The equipotential points remain same. So what is the conclusion? Equipotential points for a network are same. Okay, so that's why I told you, either you can use the parallel line of symmetry or perpendicular line of symmetry, it is going to be same. So C comma D are equipotential point. Okay, okay. Any doubt here? Tell me guys, any doubt here? Okay, and बेटा पढ़ाई पर ध्यान लगाओ. ओके, पढ़ाई पर ध्यान लगाओ, फालतू बातों पे ध्यान मत लगाओ. यहाँ पे आप पढ़ाई करने के लिए आए हो. ओके, so next point, after finding the equipotential points, next you have to redraw the network. Now this is again the important step. So tell me one point, everyone should tell me one point. If I have a branch such that the voltage is going to be equal, I have a branch such that VA is equal to VB and R is the resistor, then tell me what will be the current here. Everyone tell me what will be the current here. Everyone, if I have a branch such that two nodes are at equal voltage, okay, VA is equal to VB, if, then everyone tell me what will be the current here. Obviously the current will be zero, because the current is higher potential minus lower potential, so the current is going to be zero, right? So it will be zero, right? If the current is zero and also the potential difference is zero, so in this particular branch you have equipotential points, both current and voltage are zero, so you can convert this branch either in a short circuit or in an open circuit. What I told you, that if you find out the equipotential points in a particular branch, then you can convert that particular branch either in a short circuit or open circuit. It is not going to change the answer. Open circuit means I will represent the branch like this. Short circuit means I just bring two nodes and make it a single node. So I just bring two nodes and make it a single node, A comma C. So this is the meaning of short circuit and open circuit. Okay, got this point? So I guess there is a network problem. Wait a sec. Okay, fine. So here you can see this will be a short circuit, this will be an open circuit. Now what I am going to do, I am going to redraw the network. I am going to redraw the network. So see here very carefully. First I am using a short circuit method. Okay. So if I use the short circuit method, so see very carefully. This C and D become one node. So this C comma D become one node. Here I have a node A. Okay. So if you see that network very carefully, from A I have one resistor towards C and one resistor towards D. From A I have one resistor towards C and one resistor towards D. Similarly from B I have one resistor towards C and one resistor towards D. So see here very carefully. This is resistor, resistor and resistor. What will be the resistance AB? Okay. And don't worry guys, I will take all of your doubts. Don't worry, just I will complete this question and take your doubts after that. So what is the resistance AB? Resistance AB will be, these two are parallel and these two are in series. So you can see R is parallel to R in series with R parallel to R. Yes or no? So this comes out to be R by 2 plus R by 2 equal to R. Okay. And if I use the open circuit method, then what should I do? I have to open circuit the terminal like this. Then I have to open circuit the terminal like this. This is A, this is B, this is R, this is R, R, R. Then you can see both of these are in series. So resistance AB become R plus R parallel to R plus R, and the answer will be again R. So you can see either you can open circuit the terminal or short circuit the terminal. It is not going to change the answer. Okay. Okay. Now I will explain you this concept again in a brief form. Okay. So first take the doubt. So beta, this is the concept of symmetry to solve the questions. To Rushdie or 7 mode, this is the concept of symmetry to solve the question. Okay. Now Swati is saying balance Wheatstone bridge. Yes, Swati. This question is a balanced Wheatstone bridge question, but right now I am explaining you the concept of symmetry using this concept. Okay. Now Sheikh is asking, sir, please repeat step 3 and 4. Okay. So instead of 3 and 4, I am repeating all the steps quickly. So in a concept of symmetry, first you have to identify whether the network is symmetrical or not. To check whether the network is symmetrical or not, you just have to draw one line. Either you can draw a vertical line or you can draw a horizontal line. Then you have to see if there is a mirror image on both sides of a line. If there is a mirror image on both sides of a line, then the particular network is symmetrical network. So you can see this horizontal and this vertical line, the network is symmetrical. Fine. Next, you have to identify the line of symmetry. So line of symmetry is of two types, parallel and perpendicular. To identify the parallel line of symmetry, you have to draw the axis of a network. Now, what is the axis? Axis is the line joining the terminals of a network. Now you have to see this black line is parallel to the axis. So this will be parallel line of symmetry. This red line is perpendicular to the axis. So this is a perpendicular line of symmetry. So you have to identify the line of symmetry, but only one. I am just explaining you two line of symmetries here, but you need only one line of symmetry. After that, if you have a parallel line of symmetry, okay, अगर आपकी parallel line of symmetry आ गई है, then the branch which are perpendicular to it contain equipotential points. So in this question, this is a parallel line of symmetry, right? And you can see the branch CD. You can see branch CD is perpendicular to this parallel line of symmetry. So C comma D are equipotential points. And what happens for a perpendicular line of symmetry? The branches which are parallel to it. So see here, for perpendicular line of symmetry, branch CD is parallel to it. That's why C comma D are equipotential points. Simple. So once you find out equipotential points, you have to convert that branch either in short circuit or open circuit. Open circuit means just you have to show the open. Short circuit means I am just bringing two node and make it a single node. To make it a single node, okay, and then you just have to do once, either short circuit or open circuit, and you can see the answer will be same. There is no change in the answer, so either you can short circuit the network or open circuit the network. Okay, okay, fine, good, fine, understood. So on the same basis, now this question we are going to solve. This is a GATE 2018 question. This is a GATE 2018 question, and here I am marking the node A, B, B is already given. So here I am marking the node, so it will be A, C, D, E, F. Okay, so first of all, you need to tell me, first of all, in this question, you need to tell me the equipotential points, and then you have to solve the question. And then you have to solve the question. Okay. Okay, guys. Any doubt here? Any doubt? Again, if you have any doubt, you can ask. If you have any doubt, bacha, you can ask. And if you understood the concept, then tell me. Do you understood the concept? Yes or no? Yes or no? And guys, like the session. If you like the session, this will be your attendance when you like the session. So everyone, like the session. Still the like is come as compared to attendance. So everyone should like the session. Okay. So first of all, you need to tell me the equipotential points in this particular network, and then we have to solve the question. Okay. So I will give you some few minutes. Till then, tell me if you have any doubt. Good, Mayur, you have understood? Good. Only one student has given the answer. Okay, concept of symmetry is very, very important, because this concept is going to, because on this concept, many questions have been asked earlier. So it may happen that they can ask next time also. Okay, so everyone try this question, everyone. First you need to tell me, the first you need to tell me the equipotential points. Okay, so beta, first of all, you have to check whether the network is symmetrical or not. And one more point, beta, one more point. This question is incomplete. This question is incomplete. Actually, there is a resistance in this branch. There is a typing mistake. So actually there is a 2 resistance in this branch like this. Okay. Okay. Like this. Okay. So Ravi said C, D, E, F. Good, Ravi. Okay. Glenn, you are saying that, sir, I'm not from this club. I still like it. Good job explaining. Thanks, Glenn. So beta, see very, very carefully. Now see this question very carefully. I am going to draw one line, either horizontal or vertical. So let us suppose I am drawing the horizontal line. So if I am drawing the horizontal line, see here like this, I am able to see that above this line and below this line, I have a same mirror image. Yes or no? So the first thing is correct. The network is symmetrical. So first thing is correct. The network is symmetrical. Now, second step, you have to identify the line of symmetry. Now, to identify the line of symmetry, one thing I should do, I have to draw the axis of a network. So see here very carefully. This is the axis of a network. Yes or no? And you will see this is the axis of a network. And see here, this line of symmetry is actually perpendicular to the axis. So this is actually what? Perpendicular line of symmetry. It is what? It is perpendicular line of symmetry. Yes or no? Now, in case of a perpendicular line of symmetry, so step 2 is complete. This is a perpendicular line of symmetry. Now, step 3, I told you, in case of a perpendicular line of symmetry, branches which are parallel to it contain equipotential points. Again, I will repeat myself. In case of perpendicular line of symmetry, branches which are parallel to it contain equipotential points. So see bacha, this is a perpendicular line of symmetry. The parallel branches are CD and EF. So C comma D and E comma F are equipotential pairs. Yes or no? Yes or no? Any doubt? Any doubt? So C comma D and E comma F are equipotential pairs. Any doubt in this question? Anyone? Okay, so these are the equipotential pairs. Now see here very carefully. After finding the equipotential pair, you need to redraw the diagram. So either you can open circuit the branch or you can short circuit the branch. What I am doing? I am going to short circuit the branch. So if I am going to short circuit the branch, it means I am making C comma D one node and E comma F one node. Okay, and A comma B are the other nodes of a network. Okay, now I have to redraw the network. So see here very carefully how to redraw the network. So see here, from A I have one resistor towards C and one resistor towards D. From A I have one resistor towards C and one resistor towards D. This is 1 ohm, this is 1 ohm. Okay, from C I have one resistor towards F and one resistor towards E. So from C I have one resistor towards E and I have one resistor towards F. Similarly from D I have one resistor towards F and one resistor towards E. So I have 4 resistors in parallel, yes or no? 1 ohm, 1 ohm, 1 and 1. And finally from B I have a 1 resistor towards E and 1 resistor towards F. This is 1 ohm, this is 1 ohm. And here I need to calculate a resistance AB. Here I need to calculate a resistance AB. So see here very carefully. 1 ohm, 1 ohm. This 1 ohm and 1 ohm, it become 1 by 2. This 1, 1, 1. This 4 are the 1 ohm. So this 4, 1 ohm become the 1 by 4. And this is 1 by 2. So what will be the resistance AB? 1 by 2 in series with 1 by 4 in series with 1 by 2. So it comes out to be how much? 5 by 4. It comes out to be 5 by 4. Okay. Now ask me your doubts. Glenn, actually the line is not equipotential points. The points are equipotential points. Okay. The line CD and EF are parallel to it. Okay. The line CD and EF are parallel to it. That's why C and D are the equipotential points and E and F are the equipotential points. Okay. So guys, any doubt here? Anyone? If you don't have any doubt, just type ND. If you don't have any doubt, just type ND. And if you have any doubt, ask me. Okay, this concept is important. This concept is important, bacha. I will give you one question for homework also. On the same concept, I will give you one important question in homework. Okay, so I guess you don't have any doubt, anyone? So let's take this question in the homework. Let's take this question in the homework. My drawing is not so much good, but it can be manageable by you, I guess. This is A, this is B, this is C, this is D, this is E, this is F. Now each resistor are equal. Each resistor are equal to R. You need to find, in the first case, you need to find AD, resistance between AD. In the first case, you need to find resistance between AD, and in second question, you need to find resistance between BC. Okay, these are the two questions you need to solve. These are the two questions you need to solve in your homework. So let's take your doubt. So Bappi, Glenn, everyone is saying no problem. Prism, Bappi, you are saying prism. Beta prism is not in our course. Okay, the 3D figures are not in our course. Earlier it was in our course, so no need to worry about prism. They are not going to ask you question from prism, cube, etc. because right now they are not in our course. Glenn, actually we are discussing about the gate exam. Okay, from the EC branch and electrical branch. Okay guys, so this is your homework. Now we are going to solve the next question, this one. Okay, this question we are going to solve. See, first thing you should understand very carefully, whenever you see the network, you have 3 methods to simplify that network. Whenever you see any network, you have three methods to simplify. First one, series and parallel method. First one is the series and parallel method. Series and parallel method are the methods in which you need to identify whether they have a series branch or the parallel branch. The second method is the symmetricity. Second method is symmetricity, and the last method you should follow the star delta transformation. The last method we should follow the star delta transformation. So this is the hierarchy. First of all, you need to identify whether the network is solved by the series and parallel or not. If not, check the symmetricity. If the network is symmetrical, solve that network using symmetrical concept. And then you have, if the network is not symmetrical, then you have to go to a star delta question. So first of all, in this question, I need to find voltage across current source. In this question, I need to find voltage across current source. This is the question. This voltage I need to find. Okay. So if I am able to find out the total resistance, then voltage will be 1 milliampere multiplied by total resistance. Yes or no? This will be the answer. So indirectly they are asking us to find out the total resistance. Okay. So first of all, you will see, when you see this question, you are not able to solve this question using series parallel combination. Yes or no? Can you solve this question using series parallel combination? Yes or no? First of all, you will see 6 and 2 ohm are in series. Yes or no? 6 and 2 ohm are in series. So maybe this question can be solved by series and parallel. Okay. So check the series and parallel first. Then you have to check the symmetricity. And then you have to check the star delta method. Okay. So this is the hierarchy we should follow. So when you see this question, so first of all, you will see 2 ohm, 2 kilo ohm and 6 kilo ohm are in series because the same current is going to flow. So if these two are in series, so series combination become what? 6 plus 2 equal to 8 kilo ohm. Yes or no? This will be the series combination, right? So I can draw one resistor here which is 8 kilo ohm instead of 6 plus 2, right? Now you will see here very carefully, this 8 kilo ohm and this 8 kilo ohm are in parallel. So if they are in parallel, means 8 is parallel to 8. The resultant will be how much? 4 kilo ohm. The resultant will be 4 kilo ohms. Okay. Now I will redraw my network properly. So if I will redraw my network, so the network will look like this one. Okay, after this you can see I have a 4 kilo ohm branch. From here I have a 4 kilo ohm branch, and from here I have a 4 kilo ohm branch like this. Okay, like this 4 kilo ohm, 4 kilo ohm, this is 4 kilo ohm, this is 4 kilo ohm. Okay, so this is 4 kilo ohm and this is 4 kilo ohm like this. So now the network is somewhat simplified in this form. 4 kilo ohm, 4 kilo ohm, 4 kilo ohm, right? This is also 4, this is also 4 and this is 1. And I need to find out total resistance from here. Okay, now tell me, is there any other series and parallel combination we can form here? Tell me, is there any combination of series and parallel I can form from here? Think about this, guys. You can see very carefully. No network, no particular branches are now in series and parallel. So what should I do? Now I have to check the symmetricity. So if you check the symmetricity in this network, the network is not symmetrical at all. The network is not symmetrical. Yes or no? Is the network symmetrical? The answer is no. The network is not symmetrical. If the network is not symmetrical, then I have to check. Then I have to check the star delta transformation. Then I have to check the star delta transformation. So now what is the meaning of star delta? That we are going to understand. Now what is the meaning of star delta? That we are going to understand through this slide. So see here very carefully. A star and delta is a type of interconnection used in a network, and if you are from the electrical branch, then you know the importance of star and delta. Okay, so star delta is what? if the interconnection is given in this form such that three resistors are interconnected to one single point, I can convert this network into a delta. So for convert this network into a delta, what should I have to done? First of all, draw a imaginary delta here. First of all, draw an imaginary delta here. And one thing you should remember, when you're going from star to delta, the numerator is going to be same. I'm going to tell you how to write the formula, because if you remember this formula, you will always get a wrong answer. So how to write the formula, that I'm going to tell you. Whenever you are converting star to delta, first of all, just draw imaginary delta over star. Okay. Then you will see numerator is always remain same. What is numerator? You need to find out R1. Then numerator will be RA, RB plus RB, RC plus RC, RA. Always it is going to be same. Divide by. Now you have to see a resistor opposite to R1. So if you see the resistor opposite to R1, that will be RC. So you have to divide by RC. Similarly, if I want to write formula of R2, then numerator is going to be same. RA, RB plus RB, RC plus RC, RC divided by the opposite resistor. So what is the opposite resistor to R2? We have RB. Similarly for R3, what is the opposite resistor? We have a RA. Now case 1, if all the resistor in star are equal, means if all the resistor in a star are equal, then what happen? All the resistance in delta become 3 times of it. All the resistor in delta become 3 times of R. All the resistor become 3 times of R. Okay guys? Fine. Now next, if I want to convert delta to star. Again, if you want to convert delta to star, then you have to draw an imaginary star inside the delta like this. Now you need to find out a resistance RA. Here you need to find out a resistance RB. Here you need to find out a resistance RC. Okay. Now see here very carefully. When you convert delta to a star, the denominator is going to be same, and they are just the addition of each resistor in delta. And what is going to be numerator? For example, I need to write the formula of RA. Then you will see RA is between R1 and R3. So it will be R1 multiplied by R3 divided by summation of all resistor. If you see the RB is between R1 and R2. So R1 multiplied by R2 divided by all the resistor. Same for RC. RC is between R3 and R2. So actually this will be R3 and R2. So R3 multiplied by R2 divided by R1 plus R2 plus R3. Again the case here, if all the resistor in delta are equal. If all the resistor in delta are equal, then what happen? In star, all the resistance become equal, and it will be equal to R by 3. Okay. This concept you need to understand in case of a resistor. Inductor will going to behave like same. Inductor is going to behave like same. Not there will be no change in case of an inductor. But a capacitor will behave like a different way. For example, if I have a capacitor in star, I need to convert it into a delta. So first of all, what you need to do? Just write reciprocal of each capacitance. Just write reciprocal of each capacitance and then use the same procedure I have used in resistor. Again, I will repeat myself. In case of capacitance, you need to write reciprocal of a capacitance, and then you need to follow the same procedure we used in resistor. Okay, so in resistor, when I'm converting the star to the delta, the numerator will be same. So the same thing is going to happen here. Okay, but here what happened? In the case if CA is equal to CB equal to CC equal to C, then what happened? Each capacitance in delta become C by 3. Okay, the procedure is same, इसलिए मैंने इसको reciprocal form में लिखा है. That's why I have written in the reciprocal form, so that you need to understand the procedure is going to same. Because if you remember the formula of capacitance, that will be a difficult task. That's why you need to understand the procedure to write the formula. Similarly, if you're going delta to star, again you need to convert each capacitance in reciprocal form and follow the same procedure I used in delta to star. So in this case also, if all the delta capacitance are equal, if all the delta capacitance are equal, then all the capacitance in star become 3 times of it. Okay, so this is going to be very important, because one question will come in your exam in which you have to simplify the network. Okay, and that question you have to solve either of these 3 methods. So again, I'm going to use the star delta formation here. I'm going to use the star delta network here. So see here very carefully. This is delta. Yes or no? This is delta. So I can convert this delta into a star like this. I can convert this delta into a star like this. So in a star, if I convert, the network will look like this. If in a star I will convert, the network will look like this. Yes or no? The network will look like this, right? This is 4, this is 4, this is 4, 4, 1. But I just told you, if you are going from delta to star and each resistor in delta are equal. See, if I am going from delta to star and each resistor are equal, then what happen? It become R by 3. So here I will get 4 by 3. Here I will get 4 by 3. Here I will get 4 by 3. Yes or no? Yes or no? Any doubt here? Tell me. Sheikh, in inductor, the same thing will happen as that of a resistor. See, inductor and resistor formula wise are always same. Okay. So in case of inductor, we are going to follow the same thing. Now, any doubt here? Any doubt here? Because now simplify, you can do it yourself. Because now you will see again, this 4 by 3 and this 4 are in series, right? This 4 by 3 and this 4 are in series. And again, I can use the star delta here. So let's suppose I am using a star delta again. So again, the network becomes so much simplified. If you use the star delta again, you will see the network becomes so much simplified like this. Now nothing is left in this network. Now nothing is left in this network. The question is complete. This is 1 ohm. This is 4 by 3. This is 4 by 3. This is 4. Now here also all the resistance are same. So this become 4 by 3, 4 by 3, 4 by 3, and this is 4 by 3. Now I can find out total resistance very easily. How can you find out total resistance? Calculation you will do by yourself. These are in series, not 4 by 3, 4 by 3 and 4. These 3 are in series. Similarly, these 2 are in series, right? Aapas mein, in between them, they are in parallel and whole combination are in series. So here I can write 4 by 3 plus 4 plus 4 by 3. So it comes out to be 3 4 12, 20 by 3. Here it is a 8 by 3. Right? Now 20 by 3 and 8 by 3 are parallel. 20 by 3 and 8 by 3 are in parallel. So here I can write 20 multiplied by 8 multiplied by 3. Sorry, 20 multiplied by 8 divide by 3 multiplied by 28. Okay, just check my calculation. Okay, 3 multiplied by 28. Okay, so when you solve this question, you will get 5 8 is 40, 7 3 is 21. Okay, so 40 by 21 is the combination of resistance, this one RP, and what is the total resistance? It will be 1 plus 4 by 3 plus 40 by 21 plus 4 by 3. Simple. Okay, this is the total resistance. Okay, if you want again simplification of the formula, if you want a simplification of formula, you can write here 21 plus 28 plus 40 plus 7 4 ja 28 divide by 21. Now you just have to add 56, 57, 77 and 117 divided by 21. Okay, so calculation you can do it yourself. Okay, now ask me doubts. Let me read your comments. So Glenn, is your exam about calculating voltage? So then GATE exam is for electrical engineers. Glenn beta, GATE exams for each and every field. each and every field. Yeah, but we are the electrical students. That's why we are learning these concepts. Now, Mayur is asking, my postponed ISRO exam may be in December, January. So how do I study in the last month? Mayur, just practice the previous year ESE question, because in ISRO exam, the previous year ESE question repeat many times. So previous year ESE question plus the question from previous year AE exam. Practice these two questions and then you can get the answer. You can get the particular concept. Okay. So how I am getting a 40 by 21? By solving this particular calculation. Let me check the calculation. Calculation is correct. Okay. So how can you get this? These two are in parallel. So when R1 is parallel to R2, what can I write? R1 multiplied by R2 divided by R1 plus R2. Okay. This particular formula. So guys, any doubt here? Anyone? So I hope you don't have any doubt right now. Right. So I think you have enjoyed the lecture. I think you have enjoyed the lecture and I enjoyed it too. So tomorrow we are going to see the one of the most important theorem, superposition and a reciprocity theorem. So tomorrow class is going to be important because I am going to bring a unique question on that. Okay, I am not going to bring the same question because if you do the same question or easy question, it will be very much, you will become so much overconfident that the theorem is very easy. But I want you to solve the unique question so that you can tackle the question exam with full confidence. Okay, so tomorrow we are going to continue our this lecture and this session already. So bye guys, good night. Okay, I hope you don't have any doubts. Okay, but if you have any doubt, you can ask your doubt in a comment section. I will reply there also. Okay, so bye bye, take care, good night.